Okay, it's Mr. Brown. This podcast is for CNT140. We're going to go over Chapter 14 on telecommunications rooms. Some of our objectives really are looking at some of the specifics for our telecommunications rooms, remind us of some things about horizontal backbone cabling, look at some of the requirements for our closet, including accessibility, size, power, those sorts of things in our closet. First thing we need to kind of remind ourselves of is the standard that specifies all the pathways and spaces being our closet, is our 569 standard. If we go back in time, the A revision was in the roughly the mid-90s, 95 time frame. That kind of got the ball rolling on specifying closet requirements, that sort of thing. The B revision came along 2004 time frame, updating, and then our current C revision, 569C, came out in the 2012 time frame. And if I look at my standards document we've been using all semester, after the 568C standard, this is the end of the 568C, the 569C standard takes over or comes in place next, and this talks about the pathways and spaces in our building. So we're going to be referencing that as we go through this chapter. Before we dig into anything new, let's remember some things we already do know about our closets, which we know actually a fair amount. So let's remind ourselves. Closet, if we look at our 568 cabling structure, we have the workstation, patch cable to outlet on the wall, cabling up, up through the wall, above the ceiling, down the hall, and into our closet. So we're now looking at this part of our plan, the actual closet, the racks, the patch panels, the switches, those sorts of things. We're looking at this part of our plan now, our telecommunication room. In a multi-floor building like we would have, Midtown that we've been dealing with all semester, we would have a closet per floor kind of thing, all of our horizontal cabling coming into the closet, and then more than likely some backbone cabling connecting that to other closets in the building. So we're looking at this part, again, this part of our plan, this part of the cabling structure, if you will. And as you're noticing, it has horizontal and even some backbone in it. If I have a multi-floor, just reminding you, I typically have backbone cabling connecting, and I have a closet per floor, just as we saw in the last picture, closet per floor, backbone cabling connecting. So those are all things we had mentioned before. We've also mentioned that connecting our closets together with backbone cabling, I can do it multiple different ways. Here's your serial or daisy chain backbone where I'm just linking switch to switch. We talked about pros of this is easy, not much cabling necessary, not many ports necessary. Downside is I do have single points of failure. This switch fails, it takes out both floors. This switch fails, it takes out all three floors. We have a bottleneck here. Okay, that's your serial daisy chain. Collapsed backbone, a lot more common. There's an individual run to each floor. That does require more fiber. It does require, in this case, a kind of a concentration switch. All the switches come to it. I still do have this single point of failure, but I've gotten rid of some of my points of failure because if this link, there's a problem with this link, it only affects this floor up here kind of thing. So slightly better than our serial daisy chain. This is relatively common. And then our parallel backbone. And I kind of went crazy down here, but as you see, I have a duplicate set of equipment for everything down here at this level going out to the ISP. That's kind of, hardcore, but there's duplicate connections from each floor coming down to duplicate layer 3s and so forth. That'd be our parallel backbone. Not quite so common, but necessary in some really important facilities. You think of like hospitals and so forth that have to run 24/7, 365. Necessary in those places. So my backbone cabling connecting my closets, if I look at my three floors, the three floors haven't changed, but how I'm connecting the three floors has. So remember that that part of the plan too, my backbone cabling between my closets. My closets typically look like so. I have some racks of equipment in the middle of the room, and I'm running trays over to it to get my horizontal cabling to it. I have some conduits coming in, bringing cabling from the hall, trays into it, that sort of thing. We also talked about managing our closets. We would not want to manage a closet that looks like so. Think about trying to locate a problem cable, troubleshoot a problem cable, move a cable if somebody needs to move to a new location in the building. I would not want to manage that. I would not want to manage that. I would not want to manage that. That starts looking more like a laundry line. I would not want to manage that. Look at the It's like there's a little niche carved out for the laptop to sit in. This is one of my all-time favorites with the don't touch any of these wires, and there's even a little work light hanging on the cabling in the middle. Whew. Wouldn't want to manage that. And it's not that people plan this, it kind of evolves into this because there is no cable management to be able to organize this stuff. What I do want is this. There is cable management, and there is a plan for, as the cabling comes off the racks, how is it coming into patch panels, how is it coming into, switch to patch panel connection, those kind of things. There's a plan. Everything's bundled, everything's organized, everything's labeled, if you will. That's what I do want. These are all things we've mentioned before. This is nothing new, just trying to refresh your memory on all these things still apply to our closet. We're just going to talk more about our closets. Cable trays organizing. Here's more wire management panels and those sorts of things. Supporting the permanent wiring. Yes, I need trays into my racks, all that kind of good stuff. And then I also need supporting temporary wiring, including the wire management panels for all the patch cables and those sorts of things. Again, all things we've mentioned before, just trying to remind you. The size of our closet, we've mentioned this before. If I'm dealing with a small number of users, I can get by with a small cabinet, a small rack on the wall, those kinds of things like this. It's almost like a quarter rack anchored to the wall with some hinges on, a small cabinet on the wall, another small cabinet on the wall, even a cabinet behind a door, if you will. This would all handle a small number of drops, so I only need a small closet. Meanwhile, if I'm dealing with a large number of users, I need more space in my closet, more switch ports, more patch panel ports, more patch cables. Now I need to move into the distribution rack. 2 posts is okay for basic switch patch panel. If I start moving into servers and any rack mount switches, I'm going to need my 4-post rack. And then again, here's some reminders of what we're looking at. And this is kind of what looks like a basic switch rack, switches and patch panels. 2 posts is adequate. As I move into larger facility, I have more of them, but I also have plenty of room in here that I can add to. And I do need to plan my equipment racks out. There is actually software to do this. Now, as we get into closet layout, when we move into our bid spec, I'm actually going to have you use some software to allow you to plan out your equipment racks. So we're going to do a kind of a mini rack drawing of our racks in our bid spec, so you get the idea of what rack planning is all about. I have software to do that for you. Patch panels are located in our closet. Again, we did, if you think back in the lab, we did the work area outlet lab. And then we did the patch panel lab, and then we added patch panels to our plan. The patch panels go in the closet. There's a whole rack of, patch panels and those sorts of things in our closet. So we're now into some of some stuff in the chapter that hasn't really been mentioned before. One of the first things they talk about is phone wiring. This is kind of where we got our beginning of data wiring. We adopted the phone wiring. Phone wiring handles lower frequencies, so the standard allows for a 100-meter distance for unshielded twisted pair. Meanwhile, LAN wiring, the higher frequencies, higher bandwidths, if you will, the standard limits it to 100 meters. Well, that's nothing new. We've been saying that all along. But that kind of determines how our closets need to be laid out in our building. That's why when you think back on our bid spec, we did some of the numbers we did to select our closet locations, all based around this 100-meter idea. They remind us of the LEC, local exchange carrier. The local exchange carrier, well, this was traditionally your phone line coming into the building. This would now be your ISP line coming into the building. This enters the building at the POP or the DMARC, point of presence or DMARC. Well, that's kind of important because where that comes in, I need to route that to my MC, or my MC should be located there. So if my ISP connection comes into a certain room on the first floor of my building, if that will be able to accommodate all the routers and switches necessary for the building, that's probably where my MC should be. If not, I need to route that to the MC a relatively short distance, maybe across the hall to another room that'll be able to handle all the switches and routers and servers. But that's usually one of the criteria for the MC. Where does the ISP connection come in? Where's the local exchange carrier connection come in? LAN systems are usually distributed. Yeah, we've been kind of talking about that all along. Connections are not centralized, but instead connections are made in localized closets. Yep, we've been talking about that all along. And then the switches themselves are connected together, usually backbone links. Yep, we've been talking about that all along too. And that actually goes back to, let me buzz back here real quick, to one of these pictures back here, this idea right here. Connections on a floor come into a closet. That closet is kind of taking care of all the connections on the floor. That closet is taking care of all the connections on the floor, and then we interconnect the closets together. Yep. Nothing new that we hadn't said before. Now, let me zip back down here again. Don't look directly at the picture. Okay. So, what are some different types of closets that we encounter? Okay, well, there's roughly three. The MC or main cross connect, the IC or intermediate cross connect, and the HC horizontal cross connect. We've been kind of talking horizontal cross connect all along because of our cabling coming into the closet. Horizontal cabling coming into a closet comes in the horizontal cross connect. So let's define these other ones a little bit further. Now, this picture is actually pulled from the 568 C1 standard. This is similar to what you're reading in the book, but I'm using the standard because it's slightly more updated than what you're reading in the book. They define MC, IC, and HC. Here it is. There's the three terms that the book is using. The main closet is just that, kind of where the ISP connection comes in, where you probably have router, firewall, maybe some servers for the building. And leaving there is typically only backbone cabling. And the backbone cabling is going to go to my HCs. Okay, so I think I have, here we go. Here would be my ISP connection coming in from the street into my routers and switches, and then from there, backbone cabling is leaving to go to my HCs. Now, in this particular closet, they also have an HC as well. But this main one down here that has router, firewall, that sort of thing, possibly even the phone system, PBX for the building, or other servers, this would be my MC, my main closet, my main cross connect. Meanwhile, as the backbone cabling leaves here and goes to other closets on other floors, these up here are just horizontal cross connects. We have horizontal cabling coming into it, backbone cabling leaving. There's really not much other equipment in there. So those would be my horizontal cross connects. The other one they define, and actually here's the main cross connect, horizontal cross connect, right there, and out to the outlets on the wall. The other one they define that is optional is this intermediate cross connect. Okay, so the intermediate cross connect, let me jump down here. This is optional, and it would connect the main closet to the horizontal cross connect. This might get used in a multi-floor building. If you think of maybe a 20 or 30 or 100-story building, I might run a fiber bundle up to the 50th floor, split it out, and then have a couple horizontal cross connects up on the 50, 51, 52, because that business up there uses those three floors. So I might use a trunk line up to the 50th floor and then split it out. That split out point would be my intermediate cross connect, and then I connect to the three HCs on the 50th floor, 51st floor, 52nd floor, 53rd floor kind of thing, and then each of those floors would be the horizontal cross connect. So it's not, I was going to say it's not common, but it's not uncommon. The stuff you guys will probably encounter is probably just going to be the main cross connect, horizontal cross connect, but there is this intermediate that is optional. So if I look at my C1 standard, here it is. Here's main, intermediate, horizontal cross connect. There it is. They have them defined right there for you, then out to the outlets. If I look at the 569 standard, they have the same structure, they just call them differently. Distribution, distributor A, distributor B, distributor C, but it's the same idea, main, intermediate, horizontal, or main, horizontal outlets. That's why we have been using these pictures all along, just trying to get you oriented to the closet structure. And they remind us, okay, right here, horizontal wiring. This is the part going from the workstations to horizontal cross connect, and backbone or vertical wiring connecting my closet together, usually between my switches. So horizontal cabling coming into my closet, copper from the workstations, and then into the switches, and then I'm usually using backbone between my closets, typically fiber, between my closets. That's my backbone or my vertical cabling. All right, when we come back to the next one, we will continue on.